Hello everyone, I am Aryan Raj, a pre-final year student at IT Roorkee, and I am going to introduce you all with the topic proximity sensor in automotive vehicles. This is table of contents. We will start with the introduction part, then we will move on to proximity sensor which we use in car. We will see their applications. We will choose right proximity sensor on the basis of cost. We will see the working principle of proximity sensors, and at the end we will get to know the state of art of proximity sensor. The question is, what is use of a proximity sensor in an automobile? So, as you know, proximity sensor get idea about nearby objects without having any physical contact with them. So, we can have an idea about our environment, what is passing nearby the car. This data can help in avoiding collisions, and we can have the data of the points or the things which are not even in our visible range. Other than that, we have another advantage that we can improve our parking assistance with help of these sensors. As you can see, we have two images, the use case of the sensor in cars. So as you can see on the top left corner, there is an image where our car is moving in a highway and there are multiple vehicles surrounding our car. We can have the data of the distances of these cars which can be used to avoid any collisions on highway in case of any minor negligence. Also in this right bottom corner image, you can see there is a car which is trying to be parked, and here we can see the sensor is sensing the distance between the front car and the back car, and we can have this data to assist ourselves in parking the car and avoid any damage here. In this slide, we are going to see different kinds of proximity sensors. The type 1 is inductive sensors. These can detect metal objects, but they can't detect non-metallic objects. This is the problem with this. These have a very good detection range, but they are susceptible to interference. Then we have capacitive sensors. These can detect metal as well as non-metals, but the problem is they're short range and they get affected by dust and moisture. The third type is ultrasonic sensor. These use sound waves to measure distance, but the problem is that their accuracy is affected by temperature and sound absorption. But they are cheap and they have very short range, and they works in various weather conditions. And at the end we have lidar sensor. These use light pulse to create a high resolution 3D image. They are very expensive and they have a limited range too. We will see these three type of proximity sensor in great detail, which are inductive sensors, the capacitive sensors, and the ultrasonic sensor. We have a category classification of different kind of sensor on the basis of their cost effectiveness. We can see in the low cost range, we have inductive as well as capacitive sensors, while in moderate cost range, we have ultrasonic sensors and we have lidar at the very high cost rates. We can see the price of different kind of sensor on the basis of their per unit cost. There is a graph where we can see the capacitive and inductive sensor lie at the range of $30 to $40 per unit. We have ultrasonic sensor at the rate of $125 per unit, and we can see the lidar sensor is above $5,000 per unit, which is very expensive as compared to the previous ones. In this slide, we have on the top right corner an actual image of proximity sensor, and here we have a diagram which I will use to explain the working of the proximity sensor. This is target and this is oscillator. This sensor detects nearby objects through change in the capacitance. It comprises a high frequency oscillator generating an AC signal and sensing surface with two metal electrodes forming a capacitor. The oscillator establishes an electrostatic field around the sensor. When an object approaches, as in this case we have a target, whenever it approaches to the sensor, the dielectric properties alter the field and the capacitance between the electrodes. And then we have a threshold detection circuit, which monitors the modulated output. When the output surpasses a set level, the sensor output data state switches, which indicate there is an object nearby. As the object move away, the capacitance return to normal, and the sensor's output resets. In essence, capacitance varies due to nearby object modulates the oscillator output, establishing contactless detection. Going to get to know the working principle of inductive proximity sensor. So, an inductive proximity sensor relies on electromagnetism to detect nearby metal objects. It creates a constantly oscillating magnetic field using a high frequency current within a coil. When metal enters this field, eddy currents are introduced, and these eddy currents weak the original magnetic field. The sensor monitors the change in magnetic field nearby through the oscillator circuit. And if the change exceeds a set threshold, the sensor output switches and it indicates there is an object nearby. As in the case, we can see there is a target which will change the magnetic field due to the presence of eddy current, and hence we are going to know that there is an object nearby. Here, as you can see in the image, we have a diagram showing the change in waveform of the inductive proximity sensor oscillator in the presence and in the absence of the target. And we can set a particular threshold so we can have an idea when the target is present and the target is absent depending on the various use cases. Here we can see this is an actual image of a proximity sensor which is inductive type, and there is an image which shows working and the interior of the proximity sensor. As we have seen in the previous slide, the ultrasonic sensor work on sophisticated use of sound. They emit high frequency sound which are inaudible by the human ears, and measure the time it takes for this wave to travel to an object and return as an echo. The time of flight measurement allows them to calculate the distance to the object with high precision, as the speed of sound is same in normal conditions. Notably, these sensors excel in material independence, effectively detecting objects regardless of their composition, from metals to transparent materials and even liquids. Additionally, the ultrasonic sensor demonstrate remarkable resilience to environment factors like dust or fog, ensuring reliable operation in various conditions. As you can see in this image, uh, the sensor sends a short burst of sound which is 10 millisecond trigger pulse, and we have a 40 kilohertz sound wave. Specific the frequency, this specifies the frequency of sound by measuring the time for the sound to travel out and back. That is the distance between the sound pulse sent by the sensor and the echo. The sensor calculates the distance of object. This work even for objects of different materials, as mentioned earlier. We are going to see the state of art, which is the LiDAR sensors which are currently being used in the automobiles to avoid collisions or to assist in parking in the next video. In this slide, we are going to see the practical use case of the sensor, LiDAR sensor installed in the car. As the sensor constantly evaluates the environment, it can detect any possible chances of collision from a distance, and it enables a warning to the system user to apply a brake. And even if the user is not able to apply the brake, the system detects that too and applies a brake and stop the collision. We will see this in the two cases. Here we will see two possibilities. In the first possibility, the user will apply the brake and the collision stopped. But in the second case, we will see even if the user don't apply the brake, the system applies brake on its own to avoid collision by a very small margin. And these are the uses where we are going to save lives by using the sensors, proximity sensor in cars. Want to end the slide and thank you for listening.